Next measure of dispersion that we'll talk about is the mean absolute deviation, or the MAD of a data set. The MAD of a data set is just the average distance to the mean of the data set. The MAD is a better measure of dispersion than the range, even though it's not typically used, for reasons that we'll talk about in a later video. This diagram is showing the overall idea of the MAD. In a quantitative data set, each data value is a certain distance to the mean, and the MAD is just the mean of all of those distances. In this data set, the data values are 2, 4, 6, 8, and 10. The first data value is 4 below the mean. The second data value is 2 below the mean. The third data value is right at the mean, so it has a distance of 0 from the mean. The fourth data value is 2 above the mean, and the fifth data value is 4 above the mean. In this data set, the distances to the mean are 4, 2, 0, 2, and 4, and the MAD is just the mean of those 5 distances. In this data set, the MAD is the mean of 4, 2, 0, 2, and 4. The MAD is found by following these steps. First, you calculate the mean of the data. Second, you subtract each data value by the mean to get values called deviations. Third, you find the absolute value of each deviation. And fourth, you find the mean of the absolute values. Let's go through a couple examples of finding the MAD of the data set. This first example says, what is the MAD of 2, 4, 6, 8, and 10? First, we need to calculate the mean of the data. We can find the mean of this data set by adding the 5 numbers and dividing by 5. The mean comes out to 6. Second, we subtract each data value by the mean, and we get answers called deviations. The deviation of each data value tells you two things. First, it tells you how far the data value is from the mean, and second, it tells you whether the data value is below or above the mean. This data value of 2 is 4 below the mean, so it has a deviation of -4. This data value, 4, is 2 below the mean, so it has a deviation of -2. This data value, 6, is right at the mean, so it has a deviation of 0. It's not deviating at all. This data value, 8, is 2 above the mean, so its deviation is +2. And this data value, 10, is 4 above the mean, so it has a deviation of +4. After finding the deviations, we remove each sign from the deviations to get values called absolute deviations. So -4 becomes 4, -2 becomes 2, 0 stays 0, +2 becomes 2, and +4 becomes 4. Once we remove the signs from the deviations, we get our absolute deviations. And each absolute deviation only tells us one thing. It tells us how far the data value is from the mean. An absolute deviation doesn't tell you if the data value is below or above the mean. It only tells you the distance from the data value to the mean. So this absolute deviation of 4 is just telling us that 2 is 4 away from 6. This deviation of 2 is just telling us that 4 is 2 away from 6. So what we're looking at right here in this column are just the distances to the mean. They're the same numbers that we saw in that last slide with the x's. To get the MAD, we add the absolute deviations and divide by the number of absolute deviations. Then we get the MAD, which is the average distance to the mean. Here's another example of finding the MAD. To get the MAD of this data set, we add the 3 data values and divide by 3 to get the mean, which came out to 8. We subtract each data value by the mean of 8 to get our deviations. We remove the signs to get our absolute deviations, which are just the distances. And then we find the mean of the distances, and we have the MAD. Now that we've covered a couple examples of finding the MAD, let's discuss a few important points about the MAD. First, just like the mean, the MAD can only be found with quantitative data. It can be found with numbers like heights or incomes, but it can't be found with categories like hair colors or genders. Second, the MAD comes out to a larger number when the data has more dispersion. That's why the MAD is considered a measure of dispersion. Here are a few diagrams to illustrate the idea that the MAD comes out to a bigger number when the data has more dispersion. Let's imagine that each of these is a set of 4 exam scores. In this first data set, all of the exam scores are the same number, which means that the MAD is 0. If all of the exam scores are the same number, all of the distances, or absolute deviations, will be 0, and the mean of those distances will be 0. In this data set, 2 of the exam scores are right at the mean, with distances of 0, but one exam score is 1 below the mean, and one exam score is 1 above the mean. The distances are 1, 0, 0, and 1, and the mean of those 4 numbers is 0.5. So the MAD is 0.5. In this data set, 2 of the exam scores are right at the mean, and one exam score is 3 below the mean, and another exam score is 3 above the mean. That means that the distances are 3, 0, 0, 3. The mean of those 4 numbers is 1.5. When you add 3, 0, 0, and 3, and divide by 4, you get 1.5. So the MAD of this data set is 1.5. Overall, when the data set gets more dispersion, the distances become larger overall, and the mean of those distances comes out to a larger number. That's why the MAD increases.